you on Planetterrian Daily, episode 63, coming to you on May 14th, 2026. Here's your science and health briefing. Ancient tree rings have preserved evidence of a massive solar storm 800 years ago that produced red auroras across the sky. Analysis of thousands of modern genomes revealed a previously unrecognized ancestral group linked to the ancient Emishi people of northeastern Japan. The study also traced inherited Neanderthal and Denisovan segments associated with diabetes, heart disease, and cancer risk. This large-scale effort refines the dual origin model of Japanese population history. The same genomic dataset could help refine risk models for diabetes, heart disease, and cancer in East Asian populations. Now, shifting to a very different area of research. Columbia University researchers found that rising CO2 levels in the upper atmosphere radiate heat into space more effectively at certain infrared wavelengths. This mechanism explains why the stratosphere is cooling even as the surface warms. Most people assume every increase in atmospheric CO2 simply traps more heat and warms the entire planet. In the stratosphere, the gas behaves differently by absorbing infrared radiation and then radiating that energy outward into space at wavelengths that become more effective as concentrations rise. Right now, as you breathe, the same molecules that contribute to surface warming are accelerating heat loss miles above your head. The net result is measurable cooling of the upper atmosphere at roughly 0.5 degrees Celsius per decade in recent records. This separation between layers shows why climate models must track altitude-specific effects rather than treating the atmosphere as a single uniform blanket. Watch for future satellite data that will refine how these opposing processes interact under continued emissions. While we map ongoing atmospheric changes, the geological record shows the sun itself has produced sudden, dramatic events. Japanese scientists matched spikes in carbon-14 from ancient wood with historical reports of red auroras around 1200 CE. The data point to unusually short solar cycles and a more active sun than previously modeled. The event offers a rare calibration point for understanding solar behavior and space weather risk. Solar events leave traces across the solar system. Scientists detected iron-60 in ice cores up to 80,000 years old, confirming that the solar system is passing through material from a long-ago stellar explosion. The isotope signature offers a new window into the history of the local interstellar cloud. From cosmic debris to regional climate signals, we look at how storms in the Southern Ocean are changing precipitation patterns. Measurements from Macquarie Island show that storms now deliver substantially heavier precipitation than in past decades. The shift suggests the ocean is increasing evaporation rates, a process researchers describe as the region sweating more moisture into the atmosphere. The pattern adds to evidence of intensifying hydrological cycles in polar regions. From large-scale environmental patterns to the small-scale engineering inside living leaves, we examine an unexpected geometric solution in the money plant. Researchers mapped the pores and veins in Chinese money plant leaves and identified a natural Voronoi diagram, the same spatial arrangement used in city planning and network design. The finding shows how plants achieve efficient resource distribution without any measurement process. The arrangement allows efficient resource distribution without any central measurement process. The discovery illustrates how plants solve complex spatial problems through simple growth rules. Efficiency in living systems also depends on timely partnerships. A Frontiers in Microbiology study shows that many young insects face a time-limited game of roulette to obtain essential microbial partners. Failure to secure these symbionts within the window leads to developmental failure or death. The finding highlights the fragility of early life microbiome acquisition across insect species. From terrestrial insects to human spaceflight, we close with a compact device designed to track astronaut health on lunar missions. A Sao Paulo team developed a compact sensor that NASA will test on the Artemis II crew. The device tracks physiological markers tied to radiation exposure and other spaceflight stressors in real time. Next time, we'll be watching for results from the wristwatch device monitoring astronaut health on lunar missions. That's Planetterrian Daily for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for listening, and I'll see you tomorrow. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.